One of the things that I often run into is this challenge about DevOps and software innovation, whether or not it belongs in the government and highly regulated industries. And a lot of times in places like the government and highly regulated industries, they're faced with really rigid security controls and compliance, and those are all paramount for what they need to do. And so I'm really excited to introduce our next speaker. Our next speaker, he is Nicolas Chaillan. He's the Chief Software Officer of the United States Air Force. He's responsible for leading and enabling an Air Force software transformation of innovation to move the whole Air Force to Agile and DevSecOps capabilities. He's trying to drive all of that from the perspective of his background, in that he is an entrepreneur, having started over 12 different companies and shipped and developed over 180 different software products. So as Nicolas brings that perspective to the Air Force, I'm excited to learn more from him. Nicolas?
Hi, Nicolas Chaillan, the Chief Software Officer for the Air Force. I'm also the co-lead of the DoD Enterprise DevSecOps initiative, and I'm pretty excited today to be able to share with you the DoD's journey to Kubernetes and ISTIO and why all this matters. We'll go over quite a few slides today to share as much information as we can. But really, when you think about the value of DevSecOps, it's really about the necessity to rapidly adapt to challenges while working as a team. And for us, it's a pretty large team, as you can imagine. And on top of that, we bring a lot of different technologies. We have to bring it with us, even to space. And then, of course, with quite a few sensors. And all of that with all these people's help. So that makes our life pretty easy. And that's why we created the DoD Enterprise DevSecOps initiative, which is a joint team across DoD to bring an agnostic stack, DevSecOps stack to the DoD by leveraging open source software with Kubernetes, with OCI compliant containers. And really, I think the critical aspect of this was to bring enterprise scale services. And that's why we created two teams, Cloud One and Platform One. Cloud One is our cloud office, bringing unclassified and classified cloud access. And then we have Platform One, which is agnostic, which can run on premise, at the edge, on classified environments, on the weapon systems, on the business systems, on the cloud. And really, we built a pretty strong team to enable all these software teams across DoD to jump on the DevSecOps wagon. The first piece we built was the centralized repo of containers. Everything we do is containerized, so we centrally accredit and harden containers using also a zero trust behavior detection stack when it comes to cyber. And that's really the sec piece of DevSecOps for us. It's not just static dynamic code analysis, everyone does that. We bring next generation behavior, zero trust, cyber baked into the Kubernetes stack using a service mesh like ISTIO. We'll talk a little bit about that today. We have to train quite a few people. We have 100,000 people we have to train over a year. So we're bringing self-learning capabilities and biased content that is not pushing one product versus the other. Very important for us to be agnostic and be able to be flexible and modular. And really the concept of containers and the concept of Kubernetes and the abstraction layer of Kubernetes is critical for us. Wanted to share this website, software.dev.mil, has all the content. If you go into the DSOP document page, you're going to find all the videos, all the architecture design, the source code repo. Everything we do is open source. So the source code itself, the containers, we have everything accessible to the world. So it's a great way to give back. So it's a two-way street. Feel free to always help us as well. But you're going to find a lot of great content, training content, and the source code as well. So why did we pick Kubernetes? I think it's very important for us not to get locked in, be abstracted. So with the Cloud Native Computing Foundation, we can really ensure that the Kubernetes cluster are compliant At the same time, containers become immutable Lego blocks that can be swapped around and we can try different things. But on top of that, Kubernetes brings a ton of value when it comes to resiliency, with a baked-in security stack with what we call the sidecar container security stack, and we'll talk about what that brings, but it's really a zero trust / behavior detection stack. And then we have the Lego blocks adaptability and the ability to swap things and try things out with no downtime. Of course, automation, everything we do is GitOps, infrastructure as code, ISC, to be able to deploy the stack on any environment with no drift across classification levels for us, very critical, whether it's disconnected air gap, whether it's on the cloud, whether it's on the weapon itself, very critical that we have no drift between the dev, test, staging, and production environments. And then, of course, it auto scales based on load and really that abstraction layer make sure that the same application will run anywhere, and that's really a critical aspect. When you look at the complexity of a DevSecOps stack, and that's just one example, we have dozens of different pipelines. But if you think of all these moving parts and Lego blocks, if you had to use VMs to update and get access to the latest bits of all these moving pieces, you would probably go nuts pretty quickly. And so we are using containers to centrally scan and approve and accredit these containers, and also harden the containers using layers. And so they use the same OS, they use the same enforcement in terms of cyber scanning and behavior detection as zero trust. And so that really streamlines access to options and facilitates the accreditation of new software. And whether it's open source or whether it's commercial products, we have dozens of I think 8+ companies now pushing containers directly into the Iron Bank, which is the fancy name of our source code binary repo. So repo 1 is the source code and Iron Bank is the container repo. And so that's really streamlining access to software for DoD programs. But for companies, it's also very easy to get their software accredited as well. So everything we do is containerized. Everything is moving target defense. That's a fancy way to say we treat it like cattle and not pets, so we can kill everything and bring it back up multiple times a day as needed, which is a great way to stop bad actors from sustaining access to systems by going back to immutable state and killing the stack regularly. You end up creating that concept of a moving target defense. When you look at layers, we want to accredit layers and swap layers as needed. So we have, of course, the cloud layer or on-premise or weapon layer, wherever the application is going to run. And on top of that, we have Kubernetes, which could be any CNCF approved Kubernetes cluster. And then we have also the CI/CD pipeline on top with 172 containers. That's pretty amazing today, and it's growing fast. On top of that, we have the service mesh. The service mesh is bringing kind of this zero trust and behavior detection as well, with some of the integration we have with tools like StackRox or Twistlock or Encore. And then we have the application layer, which inherits the Delta, right? So 10% left of the NIST 853 controls. So very easy way for the application teams to implement the Delta of those, streamlining access to the continuous monitoring stack, which brings that continuous monitoring aspect. Platform 1 is kind of this central enabler of all these teams. We have so many teams building software across DoD. We have software factories, as we call them. We have science and technology research organizations. We have partners outside of DoD, inside the defense industrial base. We have tons of ventures and non-traditional startups, and of course, partners outside of the DoD with other agencies as well. And so all of these teams can now have access to Platform 1, and you'll see we bring different options when it comes to streamlining access to pipelines, all the way to production environment as well. Some of the fancy names we have that build different type of software across DoD. I'm sure most of you would love to go and work for Tron in Hawaii. Pretty good place to be. But here are kind of the list of services. And I think for any organization that's trying to scale DevSecOps, I think it's critical for them to understand we have to bring that scale managed service concept. And really, Repo 1 is the source code repo for us. Everything is there, whether it's the Kubernetes distribution suite, Hardened, the ISTIO to spin up the environments, all the container source code there. And bank is the binary side of that. So we have now way more containers. We have 120 containers approved, 170 by the end of the month. So great bank of hardened bits that are signed by DoD and can be used by anybody. This is open to the world. So Iron Bank is accessible from internet. And then we have as well the hardened distros, Kubernetes distros, with OpenShift, with Brancher, with Day2IQ, with VR, with all, with AKS, EKS. So people can go and take that code and run with it. And it's already passing the DoD requirements. It's already hardened the way we want it to be. And we go a little bit beyond the CIS benchmark. We do a lot of pretty cool stuff. So check it out. It's all on these links. And then the two main concepts of Platform 1 is the party bus and the big bang. And that's pretty important, I think, for big organizations that are trying to streamline access to DevSecOps. You need probably both of these models based on the size and the complexity of the teams. The party bus is a multi-tenant environment. So we host it, we manage it, we run everything. We pick the tools. The teams only get developer access to the environment. They don't get to pick the tools. They don't get to manage the tools. There's a cost per developer per month at multiple classification levels for us, of course, but that's very specific to the DoD. And then the Big Bang is kind of a dedicated instance of Platform 1 into a specific environment. Could be a cloud, could be on-premise to do hardware in the loop testing, or could be on a classified cloud. And really, they get to pick the tools. It's customized based on their needs, based on the mission need. We support 16 programming languages, 23 databases, so they get to pick what works for them, and it's customized to their mission. That is really the prime enabler of larger teams. The party bus can also be used for training and get people started with DevSecOps. Many don't know much about it, and they have to have a sandbox playground, and the party bus is a great option for that. On top of that, we started building quite a few training options. We obviously use commercial content from the Linux Foundation, CNCF, O'Reilly, the books, trying to bring unbiased content as much as possible. And then we have these onboarding sessions to get people started on the party bus. And we go all the way to a 2 months full onboarding that includes the team, the Platform 1 team being inserted into the existing development team to do pair programming and learn fast together and define that minimal viable product MVP with the delivery within 2 months. And that is game changing for teams that are just getting started, that are struggling to understand test-driven development, user-centered design, all these foundational concepts when it comes to Agile and DevSecOps. And particularly also the GitOps mindset of everything is code and no drift in production. So networking changes, cyber patching, all these disappear and become code change in Git that gets pulled by Kubernetes from the Git repo. We don't push. We'll talk about that as well. We have pen test services, and we even brought contract vehicles, right? So all these people used to have to go and set up contracts with different companies to get access to cloud services, to licenses, to talent. And now within 30 days, they can come to Platform 1 and just order everything they need and benefit from discounts in volumes, which is always very critical to move fast, while also benefiting from discounts that can be as significant as 75%. And so also doing better when it comes to getting more bang for bucks. And then when you look at the key ingredients when it comes to DevSecOps, and for us, we call it DevSecOps, not just because we do static dynamic analysis, that's a DevOps thing. We think of that as the continuous monitoring piece. So that includes centralized logging and telemetry, that includes zero trust with the sidecar as part of ISTIO. We use ISTIO today, but other service meshes can do the same thing, which is really a mutual TLS tunnel and denial by default and whitelisting. And then we have behavior that if a vector they happen containers, obviously they won't be any CVE. So none of the scanning CVE tools will bring much value there. That's why we look at behavior to see if the container is doing things it's never done before and proactively kill the container in that case, or alert the teams to take a look at what's going on. And then we have, of course, a huge use case with chaos engineering. And chaos engineering is all about crashing stuff to see how resilient the system can be. And very important to know how many of your containers are critical to your mission. Not everything is critical or should be critical. If you built the right microservice architecture, you can have different services with caches and more clean behavior when it comes to graceful termination. So obviously it's very complex weapon systems, and it's very important for us to know which Lego blocks are critical for that system to do its job. And so chaos engineering is a critical component of that. And of course, the GitOps mindset, and we'll talk about a little bit about the service mesh, where if you have teams moving to microservices and starting to use different type of programming languages, you don't want them to be tightly coupled. You don't want to have to coordinate releases, and you want to be able to release microservices at their own pace independently. And so you don't want to have to share bits between teams. And so authentication, encryption, all these libraries can become very toxic very quickly and have to be shared across teams. And so if you move to a service mesh like ISTIO with a sidecar container concept that is not inside the container, but alongside the container, you can update these capabilities independently. And so we will bring ISTIO to be able to do service discovery, authentication, A/B testing, canary release, fault injection, of course, east-west traffic management. So for container A to talk to B, it has to be whitelisted. That's very important for zero trust. You reduce the attack surface. You reduce what the bad actor can talk to if he managed to get access to one of the containers. And so very critical for cyber, but also very critical to be able to move at a pace of relevance when it comes to releasing software at their own pace. And so, and different service meshes as well can do that kind of decoupling and help teams move faster while being completely independent and not reinventing the wheel at the same time. So the key concept of IAC, infrastructure as code, is, and the key benefits as well is no drift between environments, right? It's immutable, it's replicable, it's automated, ideally no human in production. So you can disable ports, you can disable SSH, there's no configuration drifts, everything is code, playbooks, networking, tests, configuration changes, and you do your change management with Git. And so Git becomes your source of truth. And that's very critical to understand that if someone managed to tamper with your source code, you're done, right? So everything is code, everything is part of that change management of merge requests, pull requests, based on how many set of eyes you need to approve code change. That will define how you mitigate with insider threat, and also ensure that there is a proper change management in place before allowing anyone to just make code change. But in effect, both your testing teams and your cyber teams become developers. They have to make code change. You don't just log into SSH and start patching stuff. You make that change in code, which will then trigger the pipeline to run the proper assessment, linting, testing, and then the staging environment will pull from Git and do its own tests again. And then your production environment will then pull from Git again from a different branch, ideally your master branch, to pull that change to implement. And so when we started to move to GitOps, and we realized everything is code, that even means your seal secrets. You can have seal secrets, which is encrypted secrets. Don't put your secrets unencrypted into your source code, but you can use seal secrets. You can, of course, use Vault capabilities. But then you also have the ability to have a full desired state and declarative manifests in your Git. So by looking at your code, you should know what's running in production. You should know exactly the state of your system. And that gives you compliance auditability. That gives you the ability to do rollbacks by just doing a code rollback. Full configuration management. Disaster recovery is also streamlined because now what you're looking at is backing your source code repo and your databases, and you have everything because everything is in code other than your data. And then we use pulls and pushes, and that's critical. I think a lot of people that move to CI/CD start with Jenkins or GitLab CI or whatever CI/CD tool you're using to push into your staging or production environment. That is a non-starter for us. We don't want a push because then your CI/CD tool has the keys to your production environment, and that's a no-go. We want to do it as a pull. In effect, we have a timer, how often as you want, that will come and check your Git to see if there's any changes and apply those changes. We use Argo CD today. To do that, we can cut into smaller repos. You could have a repo per container, and then you have even a service mesh repo that's a separate team to do the whitelisting of traffic between container A and container B. So in effect, you're implementing separation of duties and need to know and least privilege by cutting your repos into smaller repos that can then be accessed by different people and have the ability to use merge requests to have a number of set of eyes. It could be one, it could be two, based on the criticality of the change to approve that change to be merged into the staging branch or the production branch. And then your Argo CD will pull those declarative manifests, desired state, YAML, operators, Helm charts, whatever the case may be, to apply them into the cluster. And in effect, you guarantee that what's your code is what's running in production. In fact, there's a whole new set of opportunities for cyber companies, which is now about comparing your production environment from your code, and if there's any drift or if there's any anything running in production that's not in code, then you have either a malicious issue with a bad actor launching something malicious, or you have potentially a drift and someone managed to bypass the pipeline and go make a change in production. And so it is very interesting to start thinking this way, but it also changes the way culture when it comes to test communities shifting left, cyber communities, which most people have not yet realized. Many cyber tools, if you use any of those fancy cyber container security tools, they all very much, even Kubernetes dashboards and capabilities on service meshes, they all have fancy dashboards that let you make changes in your production cluster, and that's a non-starter. We're just pushing the wrong behavior and educating people to do the wrong things. They should never be allowed to make changes in production. What those tools should do instead is a merge requests into that Git repo, proactively pushing code change based on the issue found. So if a cyber tool finds an issue with a container, with a YAML, whatever the case may be, instead of making the change in production, they should push that code change back, map it to the source code repo, find the right file to change in Git based on the finding, on the cyber finding. So first, map your source code repo with your production stack, tell you which file to go and change, and potentially even propose proactively the change to fix the code. And then you just have to approve the merge requests. And in effect, you automated the process. And so that is probably the future of cyber tools, but many tools are still very much focused on providing visibility and making change in production. And so that's where it's a non-starter for me to use these features. You want to disable that and not let people make change in production. What is also interesting for us is we have this concept of authority to operate. Authority to operate ATO is a very lengthy process, can take 8 to 16 months for software to be accredited to run in production. Cyber and of course, when you wait for years of software development to do this, it becomes a very cumbersome process. By doing it incrementally multiple times a day and using the principles of DevSecOps, you streamline that, and we managed to save 100 years of program planned time within 1 year of moving to DevSecOps with only 37 programs, and we're now at 60 already. So that tells you the massive time saving of adopting DevSecOps. But we created this concept of a continuous ATO, which is not about automating the documentation to accredit the software because it's a bunch of paperwork. This is about accrediting the factory, what we call the software factory, the DevSecOps pipeline, and the gates within the pipelines. And that includes testing gates, change management gates, so number of set of eyes on code change, and cyber gates. And the software that managed to pass those gates is automatically accredited. And so in effect, you accredit the factory, and what comes out of the factory is accredited. And then we authorize the teams, the people that are going to be using the factory, because they also need to have specific training, and they need to really have the right clearances and be able to have the cyber background to understand the gates. And now you have a continuous ATO. And that is obviously game changing for the department, being able to move at a pace of relevance. But this concept of those gates really apply to any commercial company, whether it's unit testing, integration testing, end-to-end testing, test coverage mandates, whether it's static dynamic analysis, bill of material scanning, dependencies of dependencies, container security scanning, based on those findings of CVEs. How do you whitelist? So we created an open source project that helps aggregate cyber findings and whitelist findings per layer. And then you can not have to reauthorize CVEs that you had to whitelist for that specific layer. So again, we're really trying to give back to the community and open source everything we do that we can open source. So it's pretty exciting to see the DoD be flexible enough to get there. And we'd love to have you guys join us and participate in those projects and have a community growing around these capabilities. We have all these containers, these hardened containers. We have this CVE whitelist capability, aggregation capability per layer, per container layer. Very interesting as well. So really wanted to share the email if you're interested to reach out to us. Again, my name is Nicolas Chaillan, I'm the Chief Software Officer for the Air Force, which, yes, is a funny title. And the email is usaf.cso@mail.mil. Feel free to reach out to us. And thank you.